Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Welcome everybody to today's episode of Pepperl+Fuchs Plugged In. Today I have Zach Stack with me. Hello, Zach.
Hello, Elga. Yeah, thank you. Appreciate you inviting me on.
Yeah, sure. Yeah. So Zach has been with Pepperl+Fuchs for almost 15 years, and his current role is market specialist for mobile automation. And I think that's exactly why we're here, to talk about something related to mobile automation. What is it that you brought us today, Zach?
Yes, Elga, that's exactly right. So basically what we want to talk about today is our PGV. So what the PGV is a camera-based guidance sensor. So basically what this can be used for is for following a track. So whether that is a colored line or a data matrix code tape, or even in some cases data matrix tags, but its main purpose is in that mobile automation world. So being used for navigation and guidance for these AGVs, any of these mobile carts, anything like that is rolling across the floor.
But we had those technology, or that particular technology, for quite a while. It's really not new.
That's right. So yeah, it has been around for a while. It's very widely used within the market as well. But what we have to really discuss today is some brand new things that are pretty exciting to bring to this market line.
Very good. And those are, drum rolls?
Yeah, so those two things are a couple brand new protocols. So the first one would be EtherCAT, and then also Ethernet TCP/IP.
Good, good. So, as always, tell us, please, what is this? What are we talking about?
So yeah, in terms of the protocol, so basically this is how the PGV sensor itself communicates its information back to your control system. So whether that's a PLC or an industrial PC, whatever that control system is that is then guiding these vehicles. So for many years, we've offered a lot of different protocols. So whether that's serial or Ethernet IP or Profinet, CAN open, quite a few different options there. So this kind of completes the whole thing, where we now offer these brand new protocols of EtherCAT and TCP/IP.
So very important for our listeners, this is not replacing anything. This is an addition. This is an extension of the line to make it more complete.
That's correct. Yeah. So this is just adding on to make it a little bit easier. I mean, a lot of times too, in these mobile automation applications, they're maybe using CAN open, but then converting it to EtherCAT just to get the faster speeds that way. So this gives you an option to go directly to EtherCAT and get that information even faster.
So that really brings me to the question, why do we have these? Why do we need EtherCAT? Why do we need TCP/IP?
Yeah, for TCP/IP, I mean, that really just adds some ease of use to the product. So with that, what you can basically do is connect the sensor itself directly to a computer-based or PC-based control system.
Raspberry Pi?
Yeah, Raspberry Pi is possible.
Single board computer?
Yes. Yeah, single board, industrial PCs, which a lot of times these are being used anyway, because in many of these applications, they're using some pretty complex navigation methods. So maybe it's LiDAR or something along those lines where they're getting that information. So this gives you another option to collect the same information via a different sensor type.
All right. So that takes care of the TCP/IP side. EtherCAT.
Yeah. So EtherCAT is interesting for the mobile automation market. EtherCAT is regarded as the fastest industrial Ethernet network. So what that kind of allows you to do is get information quicker. So generally what we're talking about with the PGV is you have a cycle rate for the PGV itself, it being a camera-based sensor. So it's taking an image every so many milliseconds. So basically then, so it'll update its information, and what the EtherCAT protocol allows you to do is collect that information faster. So when we talk about EtherCAT, generally what you're talking about is fractions of a millisecond. So as soon as that device updates its information, your control system's able to access that. And this becomes important when you're talking about vehicles that are moving maybe a few meters per second at times.
Yeah. So not only, the way I understand you, Zach, is not only can these systems now move faster, also the precision of the control is enhanced because we get information with considerably shorter delay between obtaining the data in the real world and having it in the control system. Is that correct?
That's exactly right. So yeah, it's more of a real-time data information. So like when you're talking about a moving vehicle, the more delay that you run, it's likely not going to be in the same position that it was.
Yeah.
I mean, if it's stopping or something like that, there's going to be some movement. So this really allows you to kind of get that more precise information where you're getting the position data back faster, and it's able to make decisions based on that information faster.
Zach, you started out saying that this is a well-established solution. The PGV is out there, used quite a bit. I believe on our YouTube channel, there are some videos that our audience can take a look at where these are used, why they're used, what the benefits are. Is that right?
Yeah, that's exactly right, Helga. So we have quite a few videos that are available.
Can you give me a title, maybe helping anybody to look for one?
Sure. Yeah. So we have some that are kind of geared towards the automated market. So we have one called Automated Guided Vehicle Control for AGVs with the PGV. We also have how to use the PGV for robot guidance would be another video that's available on our site, which kind of digs into this a lot more detailed than what we're discussing today.
Yeah, do you think we can provide a couple of links in the note sections to this podcast?
We definitely can. Yeah, I'll provide these links, and then they'll be available to you along with this page.
Good. So, but you told me earlier you really don't want to talk about those all that much. You want to talk about some other applications, something that might be not so well known, something new, something where we believe there is a benefit, but the PGV might not be used quite so much.
Right. So yeah, PGV is definitely established in the floor-based navigation market. But one thing that we're kind of seeing as far as the trends go is that things are moving more towards the AMR route, which is more natural feature type navigation. So along with that, there's plenty of other applications where the PGV can be used in conjunction with these autonomous robots in order to perform certain functions. So a couple examples of that would be, so let's say that you have a small bot that picks up racks and moves them around a facility. So the PGV could be mounted on the top side of the bot, which is different from if it's doing navigation. It's generally on the bottom looking at the floor. And what this does is kind of looks up and can detect one of those data matrix tags that I mentioned, maybe stuck on the bottom of the rack, and that allows it to position itself in the center point and also get some identification information off the rack. So just to make sure it's the safest position in order to lift and move these loads.
Yeah. Okay, that's a great application. What else?
Yeah, another one would be for if you talk about docking applications. So if you have an AMR that's kind of moving around and then it needs to get to an area that requires a little more precision than what it can accomplish via a LiDAR scanner or some other navigation method, then you can use the PGV in conjunction to either pull into a charging station was a good example for that, where it becomes kind of critical as to how these things are aligned to make sure the charging pads are making good contact. Or also if like a transfer station, so as a vehicle is kind of pulling up to maybe a conveyor that's moving a pallet, to ensure that when that pallet moves onto the vehicle, it's done so in the right orientation for the safest transition possible.
Very good. I think that probably covers it for the most part, wouldn't you say?
Yeah, I think that covers a good portion of it.
Good. Then you know what's going to happen. I'm going to ask you to think about a 5-word statement, the summarized takeaway. And in the meantime, I will attempt to, in a few words, summarize what you told us and what you taught us today. So let me give it a shot. So, Zach, today you mentioned an addition to our well-established PGV line of products, specifically EtherCAT and TCP/IP protocol versions. Reason for having those is that TCP/IP allows our users, our customers, to utilize PGV in single board computer, industrial computer environments, Raspberry Pi we mentioned, and EtherCAT is really the king of speed. So therefore, the precision and the feedback loop speed into an EtherCAT controller is significantly enhanced. So we provide faster updates, enabling faster speeds of the robots and also higher precision. The applications you mentioned, or the new applications, I should say, that you would like to point out were docking and also rack identification along with alignment of the bot with regards to a pallet pickup. Anything you would like to add? Anything I forgot?
I guess one other thing, just thinking about it too, is just to mention some other pretty nice features that are included in the PGV. So there are, in some of these newer models will include this as well. So one of those would be what we call a quality output. So what this means is if you're using data matrix targets, it can kind of monitor the quality of those targets over time. So if you have these harsh environments, these codes can get messed up. And what this does is give you a way to monitor that. So it can kind of give you a grade based on how many codes it can read and things like that, which is quite nice.
Excellent. Yeah, that goes into the direction of preventative and predictive maintenance.
Correct. Yes.
Excellent. Good. So, Zach, what's your 5-word statement?
Yeah, so for the 5-word statement, let's go with the topic for today, which is proven technology to new protocols.
Very good. Like it. Proven technologies to new protocols. All right, Zach, I really appreciate that you made time for us today. And to our listeners, thank you very much for listening in to today's episode of Pepperl+Fuchs Plugged In. Take a look at all the episodes we have out there. There's quite a few by now. And, well, let us know what you think. Thank you very much, everybody. Thank you very much, Zach.
Thank you, Helga.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.